Okay, so section 2 deals with solving equations using the division and multiplication properties of equality. So what I'm going to do here is just review them real quick. So first, I'll just write out, and this applies for both. So for all real numbers, A, B, C, and C is not allowed to equal 0. So A, B, and C can be anything I want, except C is not allowed to equal 0. And here's our division property. If you have A equals B, then you are allowed to divide both sides of the equation by whatever you want, as long as C does not equal 0. So that's our division property of equality. And the multiplication property of equality. All right, what this says is that if you have A equals B, then you can multiply both sides of the equation by any number you want. In this case, if you want C to equal 0, that's fine, but then that kind of ruins your entire equation. So the idea behind this is you can divide or you can multiply by anything you want as long as it's not 0, and you got to do both sides by it. So what I'm going to do is just go right into some examples, because we actually already seen a lot of this before. If you go back to chapter 3, section 5, here is where we introduce this division and multiplication property of equality. Okay? So example number 1, and you know what I'm going to do? I'm just going to write solve the following examples, because I hate writing down the directions like every single time. So solve the following equations. Let's be more specific. Linear equations, because the variables will always be raised to the first power. Okay? So here's the first equation. Now remember, the goal is to isolate the variable. Okay, that's our goal. So I look on the left-hand side, A divided by -7. So since I'm saying division, I know the opposite of division is multiplication. So what I'm going to do is I'm going to multiply both sides of my equation by the denominator. Okay? So on the left-hand side, we can see that the -7s will reduce. Okay? So I'm left over with the letter A. And then on the right-hand side, a negative times a negative is a positive, and 42 times 7 is 294. Okay? Now the next example I'm going to do, we'll do a simple one. We're going to solve -2r equals 2. Okay? So for here, read the problem. -2 times r. Since I said -2 times r, I want to do the opposite operation. So I'm going to divide both sides by -2. So that's going to give me r equals 2 over 2 is 1, and a positive divided by a negative is a negative. So r equals -1. Okay? Now, sometimes the problems can get a little bit more intense, like this. 2 over 5x equals 14. Okay? Well, with here, what I'm going to do is I'm going to multiply both sides of my equation by my denominator. Now, if you're asking yourself, well, how did you know how to do that? Remember, back in section 1, I went over these steps right here for solving a linear equation. Okay? And if you look at step number 1 says, if fractions are present, multiply each term by the LCD to reduce all denominators. Now, if we go back to the very first example, notice I got a fraction. And what I did is I multiplied everything. So I'm just going to erase so I can show you what I multiply by. I multiplied everything by my LCD. Well, in this case, it was -7 because there's only one denominator. So you can see here I multiplied this term by -7, and I multiplied that term by -7. I'm going to do the same thing for our problem right here. I'm going to look at my denominators. I got a 5 over here on the right-hand side. It's just a 1, so nothing changes there. Nothing changes there at all. And I'm going to multiply both sides by my LCD. Well, my LCD here is just the number 5. So I multiply the left side by 5, and I multiply the right side by 5. Now, on the left-hand side, the 5s will reduce. That is the whole reason why you chose 5, is so you can scratch them out. And look what you're left over with. I'll highlight it here for us so you can see it. We're left over with this 2x. So I'm going to write 2x equals 5 times 14 is 70. So from here, I'm just going to divide both sides by 2 to give me x equals 35. Okay? Now, the only way that I can make these problems more difficult is by kind of making you do more things. So let's look at some more complicated problems here. And you're going to see just how all this really starts to come into play. So we have 8x plus 9x minus 5x equals -3 plus 15. Okay? So step 1, I don't see any fractions. So I don't have to worry about multiplying by an LCD. Step 2, I don't see any parentheses, so I don't have to worry about the distributive property. Step 3, I got to look over here and ask myself, can I combine like terms? The answer is yes. So I'm going to do it. Notice they all have the letter x, and they're all raised to the first power. So I can combine all of them. So 8 plus 9 is 17, and 17 minus 5 is 12x. Equals, now I look on the right-hand side, can I combine anything on the right? The answer is yes. -3 plus 15 is 12. So step 4, I get the variable terms on one side, constant terms on the other side. It's already done. And now step 5, divide both sides by the number in front of the variable. In this case, it's going to be a number 12. So x equals 1. All right? So if I were you, if you do not have these steps right here written out on a separate sheet of paper, I would write them on a separate sheet of paper really neatly and go through every single step every single time you approach a problem. Because basically from here on out, I'll be referring to these steps over and over again. Okay? All right, let's look at another example. 7x plus 6x minus 4x equals -8 plus 26. All right, so step 1, I don't see fractions. Step 2, I do not see parentheses. Step 3, I'm going to group like terms on the left. They all have an x. They're all raised to the first power. So 7 plus 6 is 13. And 13 minus 4 is 9x. On the right-hand side, I can group the -8 plus 26 to give me 18. So this is going to be 9x equals 18. Now I get my step 4, variable terms on one side, constant terms on the opposite side. It's already done. Step 5, I look at the number in front of the variable, and I divide both sides by it. That gives me x equals 2. Okay, next example. The beautiful part about this being a video, you can always pause it and go back. Excuse me. Here's our next example. -3 times a quantity, n minus 2 minus 6 equals 21. Okay? So, step 1, I do not see fractions, so I don't have to worry about anything. Step 2, do I see parentheses? Absolutely I do. So I need to distribute. So I'm going to take this -3, and I'm going to multiply each term inside the parentheses by it. Negative 3 times n is negative 3n. Negative 3 times negative 2 is positive 6. Minus 6 equals 21. So all I did was my distributive property. Now step 3. I asked myself, can I combine like terms on the left-hand side? And the answer is yes. They're both constant terms. 6 minus 6 equals 0. There's nothing I can combine on the right-hand side. Step 4, get the variable terms on one side, constant terms on the opposite side. So that's already done. Step 5, I will divide both sides by negative 3 to give me n equals negative 7. Okay? Next example. Let's see here. I have negative 4 times the quantity n minus 2 equals 24 plus 8. Step 1, I do not see fractions. Step 2, if parentheses are present, they are. So let's distribute. I'm going to distribute the negative 4 to both terms. So I get negative 4 times n, and then negative 4 times negative 2 is going to be positive 8. So notice I do one step at a time. Okay? Now, excuse me. Step 3, I look on the left. There's nothing I can combine on the left. I look on the right. There's nothing. Oh, I'm sorry. I can combine on the right-hand side. They're both constant terms. So I get 24 plus 8, which is 32. All right, so now I need to get the variable terms on one side, constant terms on the opposite side. So I need to look at the left-hand side because that's where my variable is. Negative 4 times n plus 8. So I'm going to subtract 8 from both sides. That gives me negative 4 times n equals 24. And then finally, I divide both sides by negative 4 to give me n equals negative 6. All right. And I'm going to do one more problem here for us. I'll do one more. So we want to solve 100 minus 16 equals 4p minus 10p minus p. Okay? So here, I don't see any fractions. I don't see any parentheses. So I asked myself, can I combine on the left-hand side? The answer is yes. 100 minus 16 is 84. Now I look on the right-hand side, and I can combine all of those. So 4 minus 10 is negative 6, and negative 6 minus 1 is negative 7p. Variable terms on one side, constant terms on the opposite side. It's already done. So now, step 5, all I have to do is divide both sides by the number in front of the variable. In this case, it's going to be negative 7. So I get p equals 84 divided by negative 7 is negative 12. And that's going to be it for this lecture. It's very simple. Just follow the steps that we have outlined. The next video, we're going to be talking about solving equations with variables and constants on both sides. So this is where we're really moving things around. And then section 4 deals with fractions, where we actually have to do a lot of step 1 stuff. So I will see you in the next video. Have a good week. Later.